Awesome. Guys, once again, you're welcome. You're welcome here. My name is Eric Nudze. I'm a cloud and DevOps engineer here at Solavise Tech and also the CIO. And today we are at Solavise Tech for one of those amazing sessions, right? For me, it's one of the best sessions, one of the best, programs that I like here at Solavise Tech. Beside the podcast sessions, we have these workshop sessions which come um, every 2 weeks at Solavis Tech, where we say, hey, you know what? If you want to upskill, if you want to, get that project that can improve your resume, if you want to learn something new, something different, if you want to go away from tutorials, from the documentation and do something practical, right? Come here at Solavis Tech on these Saturday sessions, right? These are special programs that we've set up as Solavis Tech so that people can, upskill. And so here at Solavis Tech, we train our community. We have a huge community close to, I think we're getting to 1,000, 1,000 members already, right? Talk less of Facebook and LinkedIn, right? We have huge numbers there as well. And we train on cloud and DevOps. We train on AI, data science, machine learning, cybersecurity, and then very soon we are going to also start software development, right? And so today's session on our Saturday workshop, we are having Yashaswi Kakumanu. It's a pleasure to have you joining us right from India. Yash is MLOps engineer. She's also an AWS community builder, right? Don't forget. And I think that's where we even met. And yeah, the AWS Community Builders Program is one of the best programs. And it's because of this that I met Yash. Yash, it's a pleasure to have you and to learn from you. We are all gathered here to learn from you and to say you're welcome to the Solavis Tech community. And we can't wait to learn from you. And I'm going to just pass the mic over to you.
Sure.
And also to let our participants know that within the session, we are going to have an ice break, right? Maybe just for 2 minutes. Maybe just you know when you can take that pause so that we have an icebreaker, right? And so the mic is yours, Yash. You're highly welcome.
Yeah, thanks, Eric. Thanks, team and Solavis for providing me the stage. So I'll give a quick introduction about me. So my name is Yashaswi. So I have 7 years of experience in the ML and data science domain. Right now, I'm working as a MLOps and platform engineer at a healthcare industry. Yeah, today I will be deep diving into the very basic concepts of MLOps, like how do we productionize them and dockerize and then deploy it into our local machines, because productionization is the one thing the business would be taking on, right? So I'll just put some lightning points on those topics. um, yeah, maybe I'll start with my screen share for now. Can you enable screen sharing for me, Eric?
Yes, you can share now.
Okay. Hope my screen is visible.
Yes, it's visible.
Okay. So, right now, I just wanted to, for the interest of time,
Maybe,
wanted.
maybe you can check you're sharing the Zoom. Maybe you can check that you're sharing the right screen.
I think I'm sharing. Let me share. Can you see the slide over here?
Perfect. It's good now.
Okay. So for the interest of time, I just wanted to know the audience over here, have you ever trained a ML model before? So that I'll just have a fair understanding whether I should be deep diving into the basic ML concepts or there's no need of it. Maybe some heads up for that. Oh, okay. I think Kevin has already
Maybe
trained
maybe
some.
you can just they can just indicate guys just indicate in the chat if you have any basic, you say yes or no. If you have, you can just indicate yes or no. Just a yes or no, I think will do.
Oh,
Okay.
okay. Oh, I think like most of the folks have experience in like traditional ML concepts, maybe. Um, so, like in the session, like I would be talking about like how do we like deploy the models so as to be like fairly utilized by the real users today. So that's what like we would be talking about. So basically, it is very easy to build a model, but like taking it to production and then like taking it to the end users, right? It's like a one of the most painful point. um, so like here we start with the like collecting the data and then building up a model, right? Like after that, like we prepare a model or a model pickle file, and then like it stays in our like local machine, right? Like after that, like there's no point of discussion from the teammates like whether the model is like rightly consumed by the end users or it has to be deployed it into at least in stage or production, right? So this is where like right now the team would be having understanding like how can we deploy it to like various cloud providers like AWS, Google, or anywhere Google cloud providers or Databricks as well. So here like we would be talking about two main concepts like MLflow as well as dockerization of like Python functions. um, so here you could see the tracking and packaging, right? Like the MLflow would help us in tracking all the MLflow or like the machine learning models which we built on local machines, right? We could easily track all the parameters or as well as the performance metrics as well as the model pickle files that are generated over like different experimentation phases. After that, like we have to be very cautious about like how the model is packaged into like different systems or like different environments. So that's where dockerization helps us in deploying it into like various systems, like rather than working on like only one particular local machine, right? And also in the session, like I would be not deep diving into the monitoring part, like it would be just on the tracking, packaging, and then deploying the machine learning models. um, yeah. So coming to the point, MLOps, I think you guys might already know about DevOps, right? DevOps is basically structured for the software deployment lifecycle. That's where MLOps comes into the picture, where it actually brings the automation and reliability to all the machine learning deployment lifecycle process. So it's like similar to the DevOps lifecycle process, but MLOps is related or like concentrate more on the machine learning model deployment thing. Yeah, like in the today's session, like we would be deep diving into the five key components over here. The very first thing would be the scikit-learn. Like for most of the like data scientists or like early data scientists, like who are just coming into the ML platform, right? Scikit-learn is a one kind of repository where all the like supporting machine learning libraries are present in it, as well as the data sets are also like comes from the scikit-learn. So in our session, like we would be taking up a data set called wine data set, which comes from the scikit-learn again, and then from there like we would be like creating the feature set as well as the target variable, and then building up a or like training a model from it. And the second key component is MLflow, where we concentrate much more on tracking all our experiments like throughout our training phase, right? Because one day we might think like one parameter might deriving a like much more efficient or like good accuracy score, but another day like we might even improve the accuracy, right? So all these things are not recorded. I mean, of course, like we could record in our local machine, but whenever we want to pass it on to a like team member, right? Like these has to be like digitally provided to other teammates or to the entire team, right? That's where MLflow provides us a very good visualization where it could be shared across the team, so they can clearly comment and come to a conclusion saying that like which parameters or like which performance metrics like brought in like a very good accuracy on like overall experimentation phase. Like coming to the third key component is I think this is a component like which are mostly discarded by the like software engineers or the ML engineers. The thing is like we need to concentrate more on the modularizing or structurizing the scripts. It's not like a messy script like we would be creating or like passing to the other teammates. Like we need to make sure I mean ideal machine learning engineer would be concentrating or like having a like proper like visualization or like the GitHub repos, right? Like they would be maintaining it in a very proper way. So like I would also like to emphasize why the structuring of a script is needed in a traditional ML lifecycle process. Coming to the fourth main component, like the Python scripts like which we develop, right? Like all the training scripts like which we work on, like it's actually encapsulated but not like visually like viewed by other teammates, right? It has to be seen through some kind of UI, like what's the input and what's the output. So all these are like seen by a fast API, which is a like REST API, basically a HTTP endpoint where it's like a manager between the like input as well as the output. It serves as like a web service UI for the team. And coming to the final key element, like the Dockerization. So basically, Docker is nothing like a shipping container where it works everywhere or like in any system. Like right now, we are working on our local machine, right? If at all, if we want to reproduce the same thing in another local machine or maybe in some kind of cloud provider, we could utilize this Dockerization concept and then containerize and then transport it to some kind of a file and then register it, and then so that the team could be easily able to utilize the same thing. Yeah, coming to the very first point, right? Like the building, like the training phase, right? Like we pick some kind of data set. For example, as I mentioned, like we are concentrating on some scikit-learn like data sets, right? Like we train a model and then check the accuracy, and like for example, if at all if we get a like 95% accuracy, right? Like we might forgot, and then like we might move to like a productionization or like some kind of product. Like we could be telling them that like our model is like rightly evaluated or rightly trained so as to be consumed by the end users, right? But tomorrow what if we could generate an accuracy of 98%, right? All these things have to be recorded somewhere in some kind of like repo, right? So for that reason, like we utilize this MLflow where all our earlier settings could be easily analyzed and visualized for the future reference. Yeah, that's the same thing. If at all if we can't reproduce, right? Like we might forget some things and then like we can't reproduce, right? So we might think it might not happen in a earlier phase, so we might discard and then we might retrain the thing again, which would be on a very loss of time uh, for the team, right? So in order to track all the experiments like in some kind of repo, like we would be storing all this kind of in a sequential manner, like on what particular date like this kind of parameters or the performance metrics were derived, right? Like all these kind of things were like clearly seen in the MLflow UI. Yeah, the structuring part, right? Like as I mentioned, like we need to emphasize more on the structuring of like the Python scripts, right? Start from the like loading the data set, right? Like sometimes there could be a messy data, incoming data that the data engineering team might provide us. So we need to make sure all the versions of the input data that the training phase has undergone, right? Or to be like clearly recorded by the data scientist or the machine learning engineer, right? They are responsible for putting them in a like sequential process, and then ultimately like get some clarity like which data set that the model was trained on and which model was utilized in the production or this training staging phase, right? And coming to the libraries as well, like there could be some kind of libraries which are incompatible with each other. So we need to make sure all the maybe required libraries are to be present in the requirements.txt. Unnecessary libraries are to be like discarded or eradicated in the requirements.txt file. um, yeah, maybe instead of like providing the ipython notebook directly to the team, right, like we could like point them to the like github repo from the main branch and say that like by maintaining some proper readme.md file, right, like which contains the structuring, like where the data set is present in which folder, and the models and the libraries in which requirements.txt file, all the training scripts to be like clearly maintained and then mentioned in the readme.md file. Yeah. Coming to the model serving part, as I mentioned, the fast API is like a Python framework which is used to build like high performance REST APIs like very quickly. Like we would be generating a ML model, but like it might sit in our local machine, like which can't be used by customers, right? Like the fast API exposes our developed model into a like web service so that they can be easily consumed by providing the input and then get their prediction. So think of it like the communication between customer, like for example, think of it like a fast API is kind of a waiter where it provides a communication between a customer as well as to the kitchen department, right, like where they get the input, the requirement, and then serve the dish, right. So fast API works in such manner. Yeah, coming to the shipping part, right, as I mentioned, dockerizing the whole scripts, or maybe the fast API Python web framework, whole framework, right. Like right now, like we might work on our like local machine, maybe in our cloud provider, right, we might be having our local notebooks. So it there would be a situation that like we need to pass our scripts to the another teammate in a team where the teammate should be picking up from some kind of a point where we were ending, and the same code has to be worked on by other teammate, right. So that's where the dockerization comes into the rescue, where um, they could just pull the code that the other teammate has worked on, and then from there they could like pick up the script and then ultimately work on or maybe improvise the code, and then maybe they can deploy it into production like across like different cloud providers. Yeah. So I just wanted to put all the components together here, where we would be starting up with picking up a data set, where scikit-learn would be providing us a really good data set here, like wine data set. And then from there, like we would be jumping on to, going on to the training phase where we like consider the feature sets, where it would derive a like target variable. It says like which variable was like targeted, like based on the feature sets. From there, like we would be during the training phase, right, like we would be invoking all the MLflow experimentation, where it records all the experiments as well as the performance metrics, maybe accuracy, precision, recall, everything, and then ultimately gives us a very good model, which has a very good like performance metric from overall the training phase. From ultimately from all the experiments, right, like we would be getting into conclusion saying that like which model like really like provided us a very good performance metric or like the very good accuracy level. So but the best model is picked up from there, and the best model is packaged by using Docker, like from the fast API Python script, and then ultimately it is shipped to the like end users. Maybe like we'll jump to the like practical session. um, I can also share the GitHub link over here. Okay. Mm, hope my screen is visible.
Yes, it's visible.
Okay. Okay. I think this is the same thing like which I combined like from the slides like to the notebook as well. As I mentioned, like we would be deep diving into the like five like components over here, where I would start with getting up the data set, like the scikit-learn data set. Um, like prior to that, like first, like I need to create a Python environment, like where I has a like 3.13 version. I already did that over here. Like created an environment. Maybe you can do that from your end. And run this like libraries like which are required for like building up a model as well as the like dockerizing the thing. So I'll just quickly run this libraries, the scikit-learn, pandas, as well as MLflow, FastAPI thing, which are required for today's session. And also one more thing is like instead of like mentioning all the libraries like individually, like uh, this is the ideal way of mentioning the libraries. Like we need to like mention the libraries in a sequential manner in the requirements.txt file, and then we could just mention a command saying that pip install requirements.txt file. It will load all the libraries over here. Yeah. And as I mentioned, like the second key component is structurizing, right? So here, like this particular cell like would be helping us in creating a directories like app directory as well as the model directory, where app directory would contain the main Python script over here. I mean, in the next cells, like we would be working on creating the main scripts as well as like generating the models. But for time being, like whenever you run this cell, like it would simply create an empty directory like app as well as the model directory over here. And you could see here the Python version that I'm right now using is 3.13.7 over here. And also you could see these are the latest scikit-learn as well as the MLflow and FastAPI libraries. I mean, there's no need of mentioning particular version over here. Like you could simply mention the library which would get the latest library from the PyPy like repository. So basically, all these libraries are stored in PyPy libraries, which we call PyPy repository. Yeah, coming to the data set, right? Like as I mentioned, like in today's session, we are considering wine data set. Like for the interest of time, I'm not deep diving into the like wine data set, but I would just take 1 minute of time to just explain like what this wine data set contains. So basically, this is a data set which was like trained on a different wine cultivators, like which are produced in the Italy region. Maybe I can open the description over here. So basically it contains like 178 instances, in the sense like it contains 178 rows over here, where it has like 13 numeric features. Basically 13 features are contributing and providing a target variable. So right now we are working on like multi-class classification, which is which would be working on predicting whether it is a class 0 or class 1 or class 2 kind of a wine cultivator. So these are the 13 features. Those are These 13 features are trained and then ultimately generating a target variable over here. I mean, you could see all the statistics over here. For the interest of time, I'm not deep diving over here. So yeah, like here the capital X represents the features, the 13 chemical features that are responsible for predicting the wine cultivator, which is class 0, class 1, and class 2 over here. So these feature set, like the feature names are trained, and then ultimately like we wanted to get a target variable saying like which class it is, right? Yeah. And also scikit-learn has a very good libraries over here, where like we could pick up this train test split where I mean, here I'm using this 75% of the like data set would be going into like a training phase, and a rest of the 25% would be left for the like testing phase. I mean, you could even play around with like putting 80 20% or 70 30% kind of a thing, but ideal way would be like 75 to 80%. Yeah, and also it is like randomly shuffled. For that, like we are using this random state. It is randomly shuffled among the 178 samples, and then like the 75% is like brought into like the training phase, and 25% is like after the training phase, right? Like we would be considering the model, and then like the model is drawn into the picture, and model invocation might happen where 25% of the test data set is invoked to check whether the accuracy is validated or not. So here, as I mentioned, like we are using this binary classification, right? So we have to utilize the classification algorithm. So here I'm using this random forest classifier where it works really well for the multi-class classification, for like three classification we are working on right now. So random forest is nothing but like where we randomly take all the 75% training samples from 178 rows of the wine data set, and then like 50 estimators, like 50 random forests are trained, right, like parallelly, and the depth of each forest would be like the four. I mean, even you could increase the estimators as well as the depth of the like particular random forest which is picked in the like training phase, right? And then it is trained on like fitting is nothing but the training of the training data set, like the 75% data set. So from this, like as soon as like it is trained, right, this CLF would be a model, the model variable where this is invoked on our test data set, like where we split it for 25%, right? So this is the CLF model variable is invoked and then tested uh, in order to check the accuracy over here. So I mean, like wine dataset is not very complex dataset over here, so I think like it's generating a very good accuracy, like the 100% accuracy. Maybe you can pick up some complex datasets and then work on whether sometimes it could be like 92% or 95% kind of accuracy. In that case, like you could play around with increasing the estimators or increasing the depth of a tree. Or like you could check and then record like which kind of parameters like drawn like to a like very good accuracy level. um so this is like a very like naive process like which we traditionally follow in like getting the accuracy. That's where like we introduce this MLflow concept where instead of like manually like referring every time like we change the parameters, right, like the n estimators or the maximum depth of a tree, like the MLflow tracks every training phase and then it records and puts in a like nice visualization format where like we could see at what particular time or for what particular model artifact, as well as for what parameter the accuracy was generated. um, so here, right now, as I'm training on a local machine, I'm using this local database, which is kind of a local database server setup. I mean, if at all, if you go for like SageMaker, AWS SageMaker, or Databricks, right? Like they have their own database server. So right now, I'm using this local database server, which is SQLite MLflow.db, and I'm setting my experiment to wine classifier workshop, which is basically a name for my experiment. And I'll come to this part, like the train and logging part. So as I mentioned here, like we could play around with like different estimators as well as different depth of tree, right? Like here I wanted to play around with like different estimators like 20, 50, 100 and 200 over here, as well as a depth could be like 3, 5 or 10 kind of a thing. And then I'm calling this train underscore log function where it is like similar to the above function which we saw in the previous cell, where we would be passing the n estimators like for every for loop, right? Like it would be passing like 20 for 20 n estimators, like the first depth would be 3, as well as in the next for loop, like it would be for 20 n estimators, it would be 5, like fifth depth of a tree. Like in the same thing, like it would be like 4 cross 3 kind of a thing. The function would be looping on, and here you could see these are the functions which are provided by MLflow, which would help us in logging the parameters in the sense like n estimators as well as max depth, which represents, those are the terminologies which we use during our training phase. Whereas metrics are the one like which are generated after the training phase, like the performance metrics, like it could be accuracy, precision, recall, as well as F1 macro score over here. And ultimately, like we would be logging our models here, and then like can generate this estimators, like which brought like a very good accuracy. I think I'll run the script like from the start, maybe. I'm loading my data set again. Okay. So if at all, if I run this thing right, so you could see like for different parameters like 23, like there's this 95 accuracy. For 25, there's this 97 accuracy. All these are like recorded like by the MLflow, and these are present under like ML runs. Like you could see the model.pickle file, and these are like easily transported to other environments and then invoked. um, Okay. If at all, if you want to have some nice leaderboard, right, like which brought like a very good like metric, like accuracy or F1 macro score, right? Like you could get the very first row would be generating the like n estimators as well as a max depth. Okay. Um, I mean, I'm just printing out the ultimate value, which could be considered the best performance metrics that got like a very good accuracy level. So these are like concluded as the best parameters so as to take our model into the production. For example, if at all, if you want to sit in a like nice UI, right? Um, I'm just quickly running it. Mm, okay. I think I need to toggle to another. Hope you could see this MLflow thing. Local host, like where it provides us a good visualization so as to track our experiments. As I mentioned, I set my experiment name to wine classifier workshop like today. So if at all, if you click on that, like you could see all the training runs over here. If at all, if you click on this, like you could see the performance metrics, the accuracy, F1 macro, as well as the parameters that were recorded during the training phase, like the n estimators as well as the max step. And this is a good visualization for the performance metrics. Um, I mean, right now I'm not tracing any like input or output parameters, but this would be like really helpful in the production level. If at all, if there is some kind of a bug or there is some kind of nuance over there, right, in the production level, so you could come and then check the trace ID where at like at what time the bug was raised or there was error in the production. So all these were like can be neatly tracked in the production levels. I mean, right now, even in our organization, we use this traces like in our day-to-day manner. Even if at all, if we want to, like transport this, like the efficient model, right, like the good model which was like in the production level, we could like download this model.pickle file and then send it to another maybe teammate, or like we could also mention the on which particular like the library version that the model was trained on. All those things like could be like neatly encapsulated and then transported to another teammates, maybe, or to the like cloud provider. um, I think like these are the like on a very like basic level, like for the traditional ML concepts. But when, if at all, if you want to deep dive into the agentic level, right, MLflow even supports all the agentic versions. Like they could track all the like input and output parameters that the AI agent that was involved in the production. Mm. I'll jump back to the IPython notebook again. Okay. Yeah. Uh, as we saw this UI, so while explaining the slide, right, I was emphasizing more on why do we need this structurizing ML project, right? Here, I mean, you could see like uh, these are the Python scripts, or maybe like input data sets. Those are like neatly categorized and then put in like respective folder. If at all, if this doesn't come in like a neat representative manner, right, like you could not understand like under which scripts, like the Python script, the main training script, like would go under, right? Here you could see um, app folder would contain this main.py, which is basically a training script, as well as this models folder contain this model.pickle file, which is basically a model artifact. Even all the parameters as well as the performance metrics are recorded in this meta.joblib, which is basically artifact where we could not see anything. Like it has to be visualized in some kind of UI using FastAPI. um yeah. So like even here, right, like the docker file has to be present in the current directory where the main script is present. So it has to like be present in the current directory so as to take the entry script and then invoke the model artifact from the current directory. um so yeah, as I got my like best parameters, right? Like I'm just simply um like saving my model as well as like metadata, like the all the parameters into some kind of job lib, so they could be like easily like transported to some kind of machine over here. So if at all, if you run this cell, right, like in the very first phase, like you would be seeing a empty directory, like the model's empty directory. But after running the cell, these like the best parameters are, as well as the best model, would be like shifted into this model uh, like directory. Yeah. Like as I mentioned, like we need to structurize scripts over here. So I'm just like transporting all the scripts like which we ran in the earlier cells like into this train.py, where whenever we open this GitHub repo that the team is working on, right, they would be able to realize this is a main train.py script which contains, I mean, they could easily identify on which machine learning model that was trained on, like the random forest classifier was utilized for this multi-class classification problem over here. Yeah. Coming to the like how do we serve this, like we got this model pickle file, right, like the model.joblib file. I mean, if at all, if I click on this, like you're not able to see anything like what does this model contain, like how should we invoke the model by sending the input parameters, like we should be sending the input parameters, like by sending all the 13 wine cultivator features over here. So for that purpose, like FastAPI serves like a very good visualization where we could pass on our like input, like as I mentioned earlier, like it's like a waiter where it would be taking all our requirements, like the 13 features of a wine cultivator, and then ultimately getting a prediction saying that is it like a class 0, class 1, or class 2 kind of a thing. Yeah. So I'm encapsulating the whole thing in the main.py script, where fast API is like a Python web framework where it encapsulates all the job lib as well as the parameters job lib file, and then ultimately like these are the endpoints, like the HTTP endpoints, where it would be taking the input data, and ultimately passing it to another HTTP endpoint, which is a predict HTTP API, where it would be giving us a prediction over here. So I could like quickly run this as well. If at all, if I run this thing right, as I mentioned, like I am running it on a local machine. So as soon as like you run this script, like all the main.py script is encapsulated and then put it on a like local port, which is HTTP 127.0.0, listening on a 8000 port. And I think I ran this. Okay. So if at all, if you open this, right? I mean, I'll just show you. Um, Somebody has a question.
Please continue.
Okay. So the very next cell would be the feature set that we have to be like passing on to a like our model. If at all, if I run this cell, right, I mean, I'm just quickly taking up my test data set, the first row of a test data set. If at all, if you print this, right, these are the 13 features that I'm passing on to my model. And as soon as I send it to the model, or whenever it is invoked through a fast API, it ultimately produces some kind of a prediction saying that it is class 0. I take the same input over here and then click on this. Okay. 1 second. I'm so sorry. I'm handling like 2 monitors over here. So, um, okay. I think you can see my screen.
Yes.
So I'm passing the same thing to the UI as well, the fast API UI as well. So here I'm pasting this. I just wanted to get the prediction right. So here I will try out this thing, and then instead of 0 features, I need to pass my 13 feature set whenever I execute this, right? Like here it would be generating the same thing which we generated from our IPython notebook, which says that it is a class 0 for this particular test data set. Like from the 13 feature set, like it is a class 0 that was predicted. Mm, okay, let me shift to the IPython notebook again. Okay. So coming to the point where I need to Dockerize the whole fast API Python script right here. Uh, um, the very first thing is I need to create a Docker file where it starts with the same format here. It starts with a capital D Docker file. And then like we should be mentioning all the required libraries that has to be run on like different machines. For example, think the Dockerization is like a concept where shipping up the same container where it runs everywhere or anywhere in any part of the world. For example, you have some kind of a package where it works in the similar fashion, like whenever you put into like bus or truck or train or in some kind of a transportation, right, it would work in the same way, right? The package would go in the same format. So think Docker in the same manner, where we require the libraries so as to invoke our model. As I mentioned earlier, like we have this requirements.txt which contains all the required libraries so as to run by our model or invoke by our model. So this write file would simply writing the same thing into the Docker file, where the very first command would be a from Python, where it mentions there should be some kind of a base layer where it mentions the base Python image. Here right now I'm taking considering this base image of Python where it is like 3.1 hyphen slim. And I should be mentioning the current working directory where it has to pick up the scripts from. So as soon as I mention this working directory, like it would be like pointing out to the current directory, and then like copying the same requirements.txt into its into the Docker's working directory, and from there like we would be going on in installing all the requirements.txt thing. um, so in the earlier phase I mentioned there is this training script, like the FastAPI training script, right, like which comes from the app directory, which is basically a main.py. I'm copying exactly all the same Python scripts from the app directory, like all the main.py would be copied into the Docker file current directory, as well as I need to transport my model.joblib thing into the models folder, right? Like I'm copying the same thing, the meta.joblib as well as the model.joblib into the Docker current directory as well. As soon as like I mentioned all the entry scripts, which is train.py script and the model pickle file, right? Like we need to expose this Docker into some kind of a local port, like where I'm doing it on a 8000 local port, and then mentioning it to um, uh, like run this initial command, like the main.py script should be run on a in the initial phase here. I mean, this thing you can ignore where we are mentioning for the Docker file to ignore all the scripts, like basically MLflow.dp is a local server, like which you could ignore, as well as ML runs, which are the local runs, could be ignored over here. Um, so here, let me run the thing. I mean, I have run it earlier. Maybe let me open one more terminal over here. So I'm just copying this command and then running it. As soon as it runs, right, like here you could see my Docker desktop is running. Um, so here I'm just building up my wine classifier over here, and then running it on port 8000. Okay. So is already allocated. So I have in my previous terminal, right? Like it's already listening on 8000 port. So you could simply like copy this command and open one more terminal maybe, and then do this thing where it could uh, say that like which target variable was generated for this particular feature data set. Like so here you could see class 0 is the one which got predicted. I mean, I could show my Docker desktop as well. Um, okay. So if at all, if you look at my local hub, right, like you could see this one classifier is built like 1 minute ago, right? So you could do the same thing in your local machines as well. Um, okay. I mean, I just want to reiterate the same thing again, where in the very first phase, like we picked up a data set, like which is scikit-learn wine data set, and the wine data set is passed on to the train.py script, which is basically um, a script like where we run our random forest classifier so as to get the multi-class classification thing. During our training phase, like we worked on or like utilized this MLflow platform, where it is like a open source platform which could easily track all the ML experiments and manage models and compare results in a good visualized format. And the ultimately after the MLflow like experimentation phase, right, like we generated the best model as well as the best parameters which are present under model.joblib as well as meta.joblib, and then we picked up this joblib files and then packaged and then containerized whole thing on a Docker, and then expose our thing on a fast API which serves as a web API, where we could expose our model as a web service so as to like send our input features and get our prediction. I think that's all for today, where we focus more on our like containerizing as well as like experimentation phase and packaging all our Python scripts. But there's much more onto the this particular layer, right? Like where we could from this phase, like we could jump on and like deploying all the things onto a cloud provider, where it could be AWS, Cloud provider, as well as Azure, as well as we could deploy the same thing on Kubernetes as well. And we could build like a like CI/CD pipelines. Like it would be very useful for the teammates, where they could do like a simple push into the main branch, into the GitHub repo. From there, like it would be retrained or redeployed instead of like manually running all the cells, right? Like we could like prepare some nice CI/CD pipeline with single push, like all the training as well as deploying pipelines would be automatically triggered. And from there, like we could even take to a next level, where we could monitor for data quality as well as the model drift, where it focuses more on whether incoming data is like polluted or it is not relevant to the training data, right? Like all these are monitored on data quality monitoring set, as well as model drift indicates, where it focuses more on whether our model is outdated. We could like come to a conclusion that like we need to retrain, we need to go back to our roots and then retrain the model, and then get a best model again. And then all these things comes under like the monitoring phase, like which is like really useful for the production team, right? Like because they are much more concerned on like the drift detection things, because like we shouldn't be invoking the model on a like insane data set, incoming data set, right? Like every time our model should be updated as soon as there is a new features or like the new incoming data is like modified. And also like the scalability, right? Like I mean, of course it works in our local machine for sure, but whenever we are focusing on deploying the same model onto a like very larger environment, right? Like we need to focus much more on an infrastructure level, where serving our the machine learning model would be able to handle all our like larger audience, like more than 10,000 people, right? Maybe here in our local machine it works for one particular user, but whereas in our real time use case, the same thing might break down. So all those things, the latency issues as well as the CPU usage, memory usage, as well as all the client side errors are like neatly visualized in some kind of observability platform like Datadog, Prometheus, or Grafana. All these are recorded for the machine learning model deployment phase. um, I think that's all for today. Where after you run all the things that you could run the last cell as well, like where it could clear all the MLflow runs here. Mm, I think that's all I have. Any queries?
Wow, 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 wow. I think the session has been really, really, really very rich. Yeah, yeah. You said a lot of things that I was trying to just, there's a lot actually I was trying to just combine, but it wasn't, I think like I need to take a step back, right? Take a pause before I come back again. I think there's just a
Yeah,
lot to learn here. That's just a lot to learn.
yeah,
I
a
really
lot.
enjoyed it. Yes, yes, I really enjoyed it. Um, I don't know. Before I ask my question, let me go to the chat, see if there are any questions, right?
Yeah.
Um, no questions yet. But I think maybe some of them want to unmute themselves and then ask the question. Guys, what is your question? Okay, Jibo. Okay, Jibo is saying that answer questions. I thought I was going to build tools for. I guess the solutions already exist. Okay. Jibo, can you explain that? I don't understand.
Good evening, everyone from Cameroon. I'm called Jibo, and I'm from the Grace Data Science and Machine Learning program. And what I meant by that is Miss Yash has answered questions like inherently, like when I used to build models, I'll be wondering like, okay, I noticed a problem here, like there's a gap here, there's a problem here that it's going to be difficult in large scale production to this. I was wondering these concepts, considering I'm not familiar with cloud concepts. So I constantly wondered to myself that what could be the possible solution. I was like, okay, maybe I even alternated between using um BI SQL databases to save. I used to even screenshot my errors and parameters in order to remember them. And and here I am finding out that tools like this exist and these answer most of these questions. Like for a while now, when I used to do presentation on my projects I've posted on GitHub, I'll be like, the 30 minutes to my presentation, my code crashes, and it's like, how do I explain to the supervisors that, oh, this could work? It will seem as though I'm lying. But now here we are, and this session is telling us that it answers the question of it works on my machine, it works on my machine. You are able to deploy to collaborate with teammates, not just on GitHub, but on production pipelines that will have dependencies that rely on each other. Because I remember times when my code logic is perfect, and because I have different dependencies, different versions of packages, I run into issues or just lacking C++ dependencies. So here I am knowing that I can solve the problem of works on my machine. I can collaborate by containerizing my work. And I was even hoping that I would be the one to build a tool like MLflow, but it happens. So it was a very nice session, and it has covered gaps because recently these questions triggered me to go into research and and this session has answered a couple of questions I had. So thank you so much.
Yeah, thanks a lot for the good words.
Awesome. Yes, you want to add something to that?
I think this is like a very basic level I touched on today. So there's much more on like deploying part, right? So I mean, there's much more to learn, right? Like because right now I'm working as MLOps engineer, we see much more on a like monitoring level as well as tracking all the latencies and all the things which are very much concerned for the team. So those are the things like which we need to emphasize. But prior to that, if at all, if you move on to like a machine learning engineer or like MLOps engineer, right? Like these are the traditional or much more needed concepts for everyone, like to concentrate on, like before moving on to like a production level. So if at all, if you are like familiarized with the basic concepts, like you would be able to do it in a like any cloud provider. I think that's the one thing I wanted to convey here.
Okay, great, great, awesome. I saw a couple of reactions. I think from I think Kevin. I think Kevin had a question right before we started the session. He was talking about hyper something. What was that? Hyper something? Maybe Kevin.
Okay. Thank you, Ash. I think you mentioned something, and I've seen. I was actually running the notebook and also running it through as you're moving. And I love the fact that you mentioned how MLflow can keep track of the best parameters that or the best configurations that brought the best accuracy, and then from there you can register the model and that. Maybe from your own experience, I can get to know because I think there's even a time, you being a community builder, there's a time I think AWS was running this kind of, well, I've forgotten, it was a challenge for people to train models, I think on Bedrock, and then you use your model, you submit your model, then it can be taken through some tests, then it can go through a leaderboard. And the
Yeah.
biggest problem that we had a maximum, I think, of 2 models that you can train concurrently. And then after
Yeah.
you submit, then you now get ranked or something. Maybe, and the biggest problem was after you've made the tracking the best parameters that you use to get the best outcome in terms of accuracy. But from your own experience, so considering these are also things that are happening at production level, how can someone be able to do it in a more effective way, even as using MLflow?
So I think even in our current organization, right, like we rely much more on the MLflow level, where we like track all the parameters. I mean, like we are like diving on more on a like agentic level. So like all the agentic workflows are drawn into the production. So here for us, for our use case, like we concentrate on the traces, like as I was showing the MLflow UI, right? Like there's this traces like component, like where we are concerned on like how the data was inserted into the model, right? For example, there could be a user like entering a wrong input, and ultimately it might generate a wrong output, right? So but the end user might be thinking that the model might not behave in a like appropriate manner, but that's not the thing, because model is expecting in some kind of a like different input format. So all those things are like traced back, like, or then seen in like MLflow, and then we could ultimately go back to the user saying that I think you are providing some kind of wrong input format, right? So that's how like these traces are like really useful into the production level, because there could be a cases where we could there could be a billion loss of a profit for the company, right? All these were like neatly tracked, and then a reinforcement thing can be done and then communicated back to the end user saying that our model is expecting this kind of a thing, and it is behaving in a very good manner. So for all those things the MLflow is required. I mean, of course, like the business is not really concerned on like generating a really good accuracy, but they are concerned on like how the APIs are tracked, how there is a very good reduction in the latency, right? I mean, even there is like some kind of a like a wrong deviation, right? Business people are fine, but they are much more concerned on like getting a very good latency level. For example, I am working for a healthcare industry where like we would be answering to the patients, right? Patients might be looking out for a very low latency level response. So that's where like we need to concentrate on in the production level, rather than like generating an output like even the user is like they are okay to expect some kind of a wrong answer, but they are not like okay to get a very high latency level response like from the agentic level. So that's where like we need to emphasize our points, like taking the interest of the end user.
I agree with you. Maybe following up on that question is you've mentioned latency a lot, and we usually see maybe for businesses, they just want you to implement maybe some machine learning or some way of, for example, a good example is, for example, what happened for us, we have a local telecommunications provider, and they decided, okay, instead of having these standard offerings in terms of maybe internet bundles and everything,
Yeah,
when you request for a bundle, it will quickly query a model, check your buying patterns, and give you a customized offering that is very specific to you. But the challenge with that is obviously like you would, if it's a USSD, you don't want it to continue running for a long time, because if it times out, then you are
yeah,
frustrated you have not been able to buy your internet bundle, and
yeah,
there again you are supposed to start the whole process. So for you, like especially in resource constrained environments where maybe these slow network, or maybe the person's device is not that powerful, how able
yeah.
to combine all these other factors to ensure that even though you're bringing in a machine learning model in between, or forever whatever reason, even in healthcare, you still get the same, yeah, thing.
Yeah, so maybe I could mention a couple of components over here. So on an infrastructure level, right? um, like if at all if we have a budget, like we could go for GPU acceleration maybe sometimes, if at
Mhm.
all if that is possible, where it could as soon as like we get the input, right, like there would be a very good prediction in a very less time, if at all if we go for a very high level instance. If at all if we go on like a software engineering level, right, like we could concentrate on a asynchronous processing or caching level. Like the same thing, the same input could be utilized by another user as well, right? Like that's where cookies or caching comes into the picture. So we could utilize the software engineering as well. Yeah, I think like these are the main concepts like which we revolve around in getting to a like very fair enough response in the production level.
Awesome. Thank you. Thank you. Appreciate it. Cookies as well as also the instance, especially that of scaling. And I don't know, does X-ray tracing help for anything in that particular space, or tracing the API calls?
So I mean, like we could see the response time in the tracing level. Uh, I mean, like in my personal experience, right? Whenever there is a wrong input format, that was responsible in generating a very high level of response time. Like rather than, or maybe there could be sometimes server side errors as well, server side downtime as well. For example, if at all if there is a Databricks or AWS downtime going on, outage going on, right? It could also be a one of the reason for a very high response time. I mean, there are like different constraints or the situations which would influence in generating a like high latency or like very increased response time. Like we need to debug and deep dive into the root cause, like whenever there is a bug in the production.
I agree. Maybe finally, my final question would be, in terms of security, how do you ensure that your model is not susceptible to poisoning, or to act as one to jailbreak the model, or
Okay.
make the model
Um,
spit out the data it has been trained on?
I think I mean it depends upon the like the compliance agreement that the company is getting up from the external like model providers, right? Like for example, if at all if you go with the open AI models, right? Like we have a compliance agreement saying that these are like HIPAA compliant. I mean, maybe it could be like finance industry or healthcare industry. They are much more concerned on a PHI or PII data, right? So these are to be like rightly trained on a right model which is not like HIPAA compliant thing. So like we train on like GPT models, even though the models are sometimes dumb, right? Like we utilize them, like taking all the compliance into consideration, because like we should not be leaking our information to the like the patients or to the provider, the hospitals, right? That's like much more concerned because this could be like a very big risk in the industry. So I mean, people are okay with like taking up all the like lower level models rather than generating a very efficient model, but they are much more concerned on like their security level, like the compliance thing. So like yeah, to answer your question, like we do have a compliance agreement. Like whenever we are training on, right, like we have a compliance direct compliance agreement with the OpenAI team, or maybe Anthropic, or like the Claude team, right? And once we get approvals, like we go on and then deploy our models into the production.
Awesome, awesome. And obviously, they also have their own compliance certificates which they can share with you, that show that
Yeah, true.
yes, they protect the data and that kind of thing.
Yeah.
Awesome. Yeah. Thank you. Back to you, Eric. Appreciate it. Thank you,
Okay.
Yash.
All
Yeah,
right.
thank
Thank you.
you.
Thank you so much, Yash. Thank you so much, Kevin. I really learned a lot as well from these questions, right? But before I ask my question, guys, for those who are not yet in our community, kindly click the link, right, to be part of our community so that for the upcoming workshops, you should get the notification faster, right, and earlier as well. So I'm just dropping our community links in the chat so that you can join us, be part of our community, or if you haven't followed us on LinkedIn or on Facebook, just be part of us on YouTube, right? This session is going to be uploaded on our YouTube channel with the repo and everything. So guys, you might want to also follow us on YouTube as well, Facebook, LinkedIn, and join our main WhatsApp community, right? Yeah. So I think Kevin asked one of my questions already about security, but I still want to find out like if I don't know if you answered it already. When you're training your models, do you have are there instances where maybe the data set that you're dealing with, maybe you can be flagged that this data set, maybe the healthcare, since you're in the healthcare industry and you know this, it requires a lot of compliance, right? Are there
Yeah.
instances where maybe some data you've been flagged that you're not supposed to, train this data or handle this data, with that? Are there systems set in place to flag maybe some,
Uh, no, the thing
sensitive
is
data
like,
you're handling? Yeah.
yeah. So the thing is like we don't directly train on the production data. We
Okay.
just like replicate or imitate the same production data, which we call it as like de-identified data in our
Yeah.
development environment, like the QA environment. So from
Yeah.
there, like we would be uh, deploying it into stage. Even stage
Mhm.
contains the de-identified data, which is not again a production data. But once it
Okay.
goes into the production level, right, like we directly hit on like the productionized data.
Okay. Okay.
So these are actually handled by the data engineering team, where they should be providing us with a like de-identified data, because like compliance or the PHI data is like very much concerned on a healthcare level, right? So we shouldn't be training on a like actual data.
Okay. 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 All right. Great. 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 And what else again I wanted to ask? Yeah, so I know you've talked a lot, right, during this session. You mentioned a couple of concepts, and for those who are here on the call, maybe those who don't know anything about ML, they don't know anything about FastAPI, they don't know anything about Docker. What do you tell them? What should they do? Because I think they should people who said earlier on that they don't have any fundamentals. So where should they start from? What advice will you give them?
So I think I would give them by playing around with the scikit-learn. So scikit-learn provides like very good libraries, like for loading the data set, as well as giving the libraries for classification, as well as regression algorithms. So if at all, if you go into the like scikit-learn documentation, right, it clearly explains all the data sets, where to begin with, and then you can go and check the Kaggle thing as well, like where it mentions all the data sets as well. So I think I would, for the starters, I would say go with the scikit-learn thing, scikit-learn documentation, and then do your training stuff.
Okay, okay, great,
From there
great,
on,
great,
like
great.
maybe you can pick on like different MLOps concepts. Like there are like much more concepts in the um, uh, world right now.
Okay. All right. Great. Great. I think you also mentioned, if you want to push this to, you've already built a model, you want to push to the cloud, and it's just fortunate that you're talking about cloud. And when here at Solavis Tech, we offer those trainings, right? The entire AWS DevOps stack for anybody who wants to learn AWS. You want to learn Docker, right? So Jibo, you're already part of the community. So yeah, don't bother again thinking where are you going to, learn Docker, right? So you're already part of the community. And also about Kubernetes, you talked about Kubernetes is one of the areas that we also touch here at Solavis Tech, right? So for anybody who wants to learn AWS DevOps, this is the best place you can. And beside, and most importantly, data science, machine learning, right? Yeah. Yas has been talking so much about data, handling the data, right? What kind of data are you going to handle, and even the machine learning, how are you going to build it, all the steps. So if you want to learn all of that, you want to understand the fundamentals, understand the concepts, you need that foundation. You can be part of our community, right? So, and in the few months coming, we'll be launching a program, a full scale program on data science and machine learning, and also on AWS, right? So you don't want to miss this opportunity. Yes, you don't want to miss this opportunity. This is Josh here, who's already working in the healthcare space, and the healthcare space, people use a lot of ML. There's a lot of machine learning around the healthcare space, right? So we want to take advantage of that and be part of a community, right? Yeah. And then just within this session, before we started, there is something that we want to share with you, want to celebrate with you if you're joining us here for the first time or if you haven't heard about it. Kevin is here. He's been traveling since last week, I think last 2 weeks, right? He attended or took part in a competition with the Kenyan community. And this was the Huawei, I think that should be the 10th competition, right? Kevin, if I'm correct, the ICT competition, that should be the 10th, right? Yeah. And they won the grand award, right, for that competition. Yes, that competition, the entire, out of all who participated, the Kenyan team, which was led by Kevin here being the CTO here at Solavise Tech, they got the award, and you can see him. That's the award that he got. So guys, let's give a shout out to Kevin and the team. Let's give a shout out to them. I think we are really opportune, right? We're really opportune. A few days back, I saw somebody said, you don't know when you have access to certain people, try to take advantage of them. Yes, when you have access to certain people, try to take advantage of them until you lose them before you think that, oh, if I had known, right? So Kevin is here, he's quite exposed. There are a lot of things that I always reach out to him, right? A lot. And he's always been an inspiration to me and for all of us here at the Solaviste community. Right? So Kevin, want to say congratulations from the Solavise Tech community, and to say this is just the beginning. For me, it's always the beginning. Whatever you're doing in life, always take it as a beginning, right? If you got the greatest
Yeah.
award, take it as a beginning. Yes, there is more to
Exactly.
achieve. There's a lot of potential in you to achieve, right? Yeah. Just to add to that, a few days, I think yesterday, when Elon Musk was announced as the first billionaire. And for me, that didn't even interest me a lot. But when I listened to the podcast when he was talking about SpaceX, he was sort of looking at the potential that the world has, that the Earth has. And he said, we haven't even attended one quarter of that for the Earth's potential, right? That's to tell you that in each and every one of us, there is a potential that you can tap from. So you need to look within yourself, look at the potential that you have, look at what you can, give out to the world. And Kevin is just doing that, and I'm also trying my best to do that. Just yes, he's also doing that, giving us the potential, in any way that you can. So also try as much as possible to make sure that you give us something to the world, right? And this is just the beginning. Again, thank you so much again for being part of this workshop session. Josh, we want to thank you. I don't know if you have any last word for us before we close the session.
I think I would thank Eric and Solavis team and Kevin as well, like for having me here today. Yeah, I think it's
Okay.
great interacting with
All
all
right.
of you folks.
For sure, for sure, for sure. And we hope to invite you in the upcoming sessions in any way
Sure.
possible. Right. It was really amazing. I really like the way you are taking it so slowly, like without any breaks, right? Yeah, you know your thing, like we say, yeah, like you know your thing. You know your stuff, right? Yeah, I really enjoyed it. I really enjoyed it. Yeah, so Kevin's saying, working 16 hours a day, 7 days a week, 52 days weeks a year, and people still calling me lucky, right? Yeah. That's Elon Musk for you. That tells the amount of work that's
That is the
required.
part I love from Elon Musk, because it makes me
I like
realize
that.
that according to him, I'm lazy.
Uh-huh.
According to me, the way I'm thinking, I'm still lazy.
Exactly, exactly. So guys, it's been an amazing session. Be part of us if you are facing any challenge, if you want to learn about ML, you want to learn about this concept, Docker, FastAPI, anything, right, around data, cloud, AI, right? This is the best place. And don't forget to spread the message. Don't forget to spread the message, and see you in our WhatsApp community and on our social media platforms. So it's been an amazing session, guys. Thank you all, and enjoy the rest of the weekend.
Yeah,
Bye bye.
thanks a lot. Yeah.
Thanks.
Bye bye.
Oh, sure. Bye. Yeah.